So now that we know a little bit about how radicals work, let's see how we can solve some equations that have radicals in them. So we'll start off with a fairly straightforward one, something like this. The square root of 7x is equal to 10. Now, of course, the point of solving this equation is to try to get x equals a constant, right? X by itself on one side of the equation. So the first thing we need to do is get the 7x out from under the radical. This is a square root, so we can actually undo this fairly easy by just squaring it. The square and the square root will kind of cancel each other out. And then, of course, since it's an equation, I must do the same thing on the other side of the equation. So I'll end up getting 7x. End up getting that 7x is equal to 100. And then, of course, I can divide by 7, and I'll get 100 over 7. Now, here's the trick. Anytime that we take an equation and square both sides, it's possible that we're creating answers that aren't real. It's possible that we're getting some answers that are false, some extraneous answers. So what we always have to do when we square both sides of the equation is we have to check the answers, because it's possible that our answer, in fact, does not really work. So I'm actually going to check this. If you just get in the habit of always checking your equations, then you don't have to worry about when to do this or not. But in this situation, we always definitely have to. So I'm just going to take this and check it by putting it back into the original equation and see if it works. So this will be the square root of 7 times 100 over 7, and I want to know, is that equal to 10? Well, is the square root of 100 equal to 10? Sure, that one's fine. So this answer stands. We don't have to do anything with it. If we go through and check and end up getting an answer that doesn't work, like taking the square root of a negative or something like that, then we're just going to kick that answer out if it doesn't work in our equation. So we'll keep the ones that do work, and anything we go through and it doesn't satisfy the equation, we'll just boot it out and we'll say that was an extraneous answer that we got. So let's try one that's a little more sophisticated. How about an expression like this? In this situation, I have the variable here twice, x twice, but I can't combine them together because this is the square root of x, and this is just x to the first power. So what I'd like to do is first isolate the radical. So I'm going to isolate the square root by itself on one side of the equation before I do any squaring. So now that I have this isolated, I can now go through and square both sides. And then the square and the square root, I'll just get x here, they'll cancel out. And then I have to FOIL this, x minus 2 squared. Now I'm getting x squared minus 4x plus 4. Okay, then I can subtract over my x, and I'll get minus 5x here, x squared minus 5x plus 4. To solve this, this is a quadratic equation now, so now I need to factor this. And this will actually factor into x minus 4 times x minus 1. So I get two answers here, x equals 1 and x equals 4. Now, but remember, we went through and squared both sides of this equation, so it's possible some of my answers are extraneous. So I have to go through and check it in the original equation before you did any squaring to see, is this going to work? Okay, so let's start with x equals 1. So I'm going to put this in for both places of x. So the square root of 1 plus 2, is that equal to 1? Well, the square root of 1 is 1. And we take that plus 2, we get 3 equals 1, which is not true. So we're going to end up actually just throwing that one away. That's an extraneous answer that we get. Because remember, we're not taking the positive and negative version here when we take this square root. That only happens if we have something like x squared is equal to 1, and then we take the square root of both sides, something like this. If we took the square root of both sides, remember the square root of x squared is the absolute value of x, and in that case we would get the positive and the negative version. But when we're just taking the square root of the constant, we just take the positive there. So try not to get confused with that. I know it's slightly confusing. But let's check the other one, x equals 4. Okay, so if I take the square root of 4 plus 2, is that equal to 4? Well, sure, square root of 4 is 2, and then 2 plus 2 is equal to 4, so that one works great. I'll take that answer and I'm going to throw away the x equals 1 as an extraneous extra answer. Okay, let's look at another one. Something like this: the square root of 3 minus 2x minus 2 is equal to 0. Again, before you square both sides to try to get rid of that square root, try to get the square root by itself, or you need to get the square root by itself. Isolate the radical on one side of the equation. So I can do this fairly easily by adding 2 to both sides. So the square root of 3 minus 2x is equal to 2. Now when I square both sides, the radical will go away. This square root and that square will cancel out. I'll get 3 minus 2x is equal to 4. And so that means I can subtract over the 3, and I'll get minus 2x is equal to 1. So x is equal to negative 1/2. And of course, we have to check this because we did some squaring here. So we need to see if this answer is legitimate. So we're going to plug this back into the original equation before we did anything to it. Let's plug in x equals negative 1/2 to check. Okay, so is the square root of 3 minus 2 times the negative 1/2 minus 2 equal to 0? Well, square root of 3 minus, this will be plus 1. Okay, negative 2 times negative 1/2. So this will be square root of 4 minus 2. Is that equal to 0? Really, I should put question marks out here because I don't know if this is true. Well, sure, 2 minus 2 is equal to 0. Yeah, so that's a good answer. We'll keep x equals negative 1 as a solution to this equation. What about one like this? The cubed root of y plus 1 is equal to 6. Now in this case, I'm not dealing with a square root, but a cubed root. So if I want to undo this radical, I don't need to square both sides, but instead I'm going to cube both sides. And this cube and this cubed root now will cancel out. So I end up with y plus 1 is equal to 216. Now simply subtract over the 1, and I'll get that y is equal to 215. I can check this. I shouldn't have any problems since I cubed instead of squared, but we'll just make sure we'll check. So I'll take the cubed root of y plus 1 will be 215 plus 1 is the square root of that equal to 6. Well, this will be the cubed root, sorry, not the square root, the cubed root. The cubed root of 216, which, yeah, that is equal to 6. So we'll take that as a good answer. Now it's possible that you'll end up with an equation with more than one radical in it. And that's okay. There's a couple of different varieties that they come in, so let's take a look. This is probably the simpler version, something like this. The square root of 2x minus 7 is equal to the square root of 3x minus 12. In this case, I have just a square root on one side, a square root on the other side. If I go ahead and just square both sides, like so, they should automatically cancel out with each other, and then I end up with this expression, 2x minus 7 is equal to 3x minus 12. Subtract over the 3x, and I'll get negative x here, add a 7, and I'll end up getting negative x is equal to negative 5, which means that positive x is equal to positive 5. We'll check this real quick. So if I plug in x equals 5, 2 times 5 minus 7, and the square root of that, is it equal to the square root of 3 times 5 minus 12? Well, this will be the square root of 10 times 7, and this will be the square root of 15 minus 12. So this will be the square root of 3. Is that equal to the square root of 3? Well, sure, those are both the same number, so this one checks out. So this is a totally fine answer. This works well. The one that we will have two radicals that is a little trickier is one that looks something like this. So this will be the square root of 2x plus 3 is equal to 3 minus the square root of 2 times x. Now if you notice on this one, no matter what I do with the 3, I can never get just a square root of something on one side and just a square root of something on the other side, because I can't combine this 3 with any of these radicals. So in this case, I'm actually going to end up having to square this thing twice, and I'll show you what I mean. I'll start off by getting it moved around as much as I can. So I have just one radical by itself on one side. That's the best I can do right now. So I'm going to go ahead and square. So we'll square this left-hand side, so the square root of 2x plus 3 quantity squared. Now when I square this right-hand side, I have to square it the entire side, so actually I'm going to have to FOIL the right-hand side. The left-hand side's nice, right? The square root and the square will cancel out, and I'll end up getting 2x plus 3. But over here, I'll still end up with some radicals. So if I FOIL this, I'll get 3 times 3, which is 9, and then 3 times negative square root of 2x, and then another negative 3 times square root of 2x. So this will be negative 6 times the square root of 2x. And then the negative square root of 2x times the negative square root of 2x, so that'll be a positive 2x, and so it will be square root of 2x squared. I'm assuming everybody has had a lot of practice with the foiling, so hopefully you're comfortable with it by now. Now what I want to do is clean up the equation, and then now try to isolate this radical by itself, square the equation one more time. So this 2x and this 2x, if I subtract them, they'll cancel out. Then I can subtract over this 9, and I'll get a negative 6 here, and that's equal to negative 6 times negative 6 times the square root of 2x. I could go ahead and square both sides now, but then I would have to square this negative 6, and I'll end up with bigger numbers. So the first thing I'm going to do is just divide the whole thing through by negative 6. So negative 6 here, negative 6 here, and end up with this expression, negative 1 is equal to the square root of negative 2x. Now at this point, it's a good point to square both sides again. So simplify it as much as you can before you go to square the second time. So now I'll end up getting 1 is equal to 2x. So x is equal to 1/2 is what my answer should be. Now let's check this. Now remember, you have to check it in the very original equation. If you check it in anything down here, it doesn't mean anything, because at this point you've already squared. That's how you got the answer in the first place. So let's check it in our original equation. So the square root of 2x plus 3, this will be the square root of 2 times 1/2 plus 3. Is that equal to 3 minus the square root of 2 times 1/2? Is this a true statement? 2 times 1/2 is 1, so I end up getting the square root of 1 plus 3. Is that equal to 3 minus the square root of, again I'll get 1. So this is the square root of 4. Is that equal to 3 minus the square root of 1, which is 1? So the square root of 4 is 2, and then 3 minus 1 is 2. So yeah, that's a perfectly good answer. We'll keep this x equals 1/2 as an answer to this equation. So you can see one like this takes a few extra steps. You'll have to do a little extra work to it, but it's still kind of the same process. You go through, square both sides, clean it up as much as you can, isolate the radical, square both sides a second time. Hopefully that's all you'll have to do to where you can solve it for x. Then of course, check your answer. So the last type of equation I want to look at is one where the exponent is actually a rational exponent instead of written in the radical form. In this case, I have x to the 2/3 is equal to 25. Well, what I'm going to do in this case is actually kind of break this up. I'm going to think of this as x to the 1/3, all of that squared. Remember, I can do this using my laws of exponents. This is no problem. And all of that's going to be equal to 25. So now what I'm going to do is actually get rid of this squared by taking the square root of both sides. Now I have to be very careful here. Really taking the square root, I'm going to take it to the 1/2, Or I could maybe just write this as the radical to make it a little nicer. Now be careful, if anytime I take the square root of something squared, it's not just that answer, it's the absolute value of that answer. So if I take the square root of x to the 1/3 squared, it's actually the absolute value of x to the 1/3. This is a rule I talked about a little earlier. The square root of, for example, y squared is equal to 4. This means that the absolute value of y is equal to 4. Anytime you take the even root of something that's raised to an even power, that exact same even power, for example, the 4th root of something to the 4th power, or the square root of something to the 2nd power, it always becomes the absolute value. And the reason that is because then you can split this up and say, oh, it can be the positive or the negative version of this answer. So here I'm going to have the absolute value of x to the 1/3. So that means I'll have to split this up and say that x to the 1/3 is equal to 5, or x to the 1/3 is equal to negative 5. If you remember when we were back a while in the class when we were dealing with absolute values inside of equations, we always had to split it up like this. So now I would just cube both sides to get rid of the 1/3. So 5 cubed here, and then negative 5 cubed here. Again, the reason I'm cubing this is because 3 times 1/3, this becomes just x to the 1st, and then 5 cubed is 125. Here I'll get the same thing, x to the 1st, and then negative 5 cubed. Remember, this is negative 125, since when you can cube, you can either get a positive or a negative. So in this case, I'll actually get 2 answers here. Now I could have done the opposite way. I could have cubed this first and then taken the square root. But the problem is cubing 25, that's a really big number, and then when you try to take the square root of that, it might be hard to figure out. So I kind of used my judgment here to say, well, I know what the square root of 25 is, so I'll do the square root of that first. That makes this a smaller number that I can then cube after that to get a relatively easier number. If you cubed first and then took the square root, you get the exact same answer, but it would be more difficult as far as arithmetic goes.